Module 4. Scope Planning. As we venture into the realm of project management, we must acknowledge that the cornerstone of a project's success is its scope planning. This chapter will guide you through the art and science of scope management, the meticulous process of collecting requirements, and the significance of defining project scope. Imagine scope planning as charting the course for a ship's voyage. The project manager, akin to a captain, must outline the journey ahead. It begins with the crafting of a scope management plan, a document that serves as the navigator, ensuring the project stays its course amidst the winds of change. The planning of scope management involves drawing up procedures for how the project's scope will be defined, documented, and approved, setting the stage for the project's trajectory. Next, we dive into the deep waters of collecting requirements. Through engagement with stakeholders, a project manager gathers the myriad needs and expectations, similar to a cartographer drawing a map of the lands to be explored. This ensures that every voice is heard and every need is considered in the project's blueprint. Upon having all requirements in hand, we define the project scope. This is not merely listing the tasks, but creating a comprehensive document that details the project outcomes and products, akin to detailing the ports of call and the treasures to be found there. This detailed specification is the defined scoped process, shaping the boundaries within which the project sails. As we plot this course, we introduce the requirements traceability matrix, a tool as vital as a compass. It allows us to track each requirement from its origin through to the final deliverable. This matrix is our assurance that we do not stray from our intended path, maintaining a clear linkage between stakeholder expectations and project deliverables. Let us now consider the work breakdown structure, WBS, which is to project planning what a detailed itinerary is to a traveler. The WBS is a decomposition of the project into smaller, more manageable segments. The answer to question 23 is B. Each segment is a stepping stone towards the final deliverable, and their collective assembly forms the project structure. This breakdown is crucial for project planning and control, as it allows for a granular approach to task assignment, progress tracking, and resource allocation. The development of a WBS can take many forms. Some project managers may choose a methodical, top-down approach, while others may opt for a more agile, iterative method, adapting the WBS as the project evolves. The method chosen often depends on the project's nature and the industry's best practices, allowing for a tailored approach to project management. Within the life of a project, changes are as inevitable as the changing tides. To accommodate these changes, a project manager must be prepared with a change request form. This form acts as a formal proposal for alterations to any aspect of the project plan, be it the documents, deliverables, or baselines concerning scope, cost, or time. It's the mechanism by which the project adapts to new circumstances while maintaining control and order. Now, let us cast an eye over the horizon to foresee potential challenges in estimating activity durations accurately. In this journey, omissions are like uncharted waters that threaten the voyage. A project manager must navigate these with care, refining the scope statement and WBS to ensure that no requirement is lost at sea. Leveraging checklists or templates from previous voyages can help in avoiding these pitfalls. The seas of project management are often shrouded in the fog of general uncertainty. To see through this, a project manager can utilize the concept of the learning curve, studying past improvements to predict future timelines more accurately. Additionally, employing rolling wave planning allows for detailed planning for imminent work, while future tasks are outlined in broader strokes. This adaptability is essential, as it allows the project to remain flexible and responsive to change. As we sail, we must also consider the common cause variations, the currents and winds that might shift unexpectedly. Here, the PERT technique is like a seasoned sailor's intuition, creating 3 estimates for each activity: optimistic, most likely, and pessimistic, and using these to chart a course that accounts for all eventualities. Finally, the issue of queuing, akin to waiting for the tides, can be addressed by staggering project start dates or employing strategies such as resource leveling or resource buffers. This ensures that our resources are not overburdened, allowing for a steady and sustainable voyage towards project completion. In the end, the journey of scope planning is one of vision, adaptability, and precision. It requires a project manager to be a visionary, charting out a path that not only achieves the project's objectives but also responds to the ever-changing environment. It's a delicate balance, like navigating a ship through both calm and stormy seas, ensuring that the destination is reached as planned, and the treasure of project success is realized. Scheduling projects. In managing a project, the schedule is a dynamic entity, an ever-evolving blueprint of the project's timeline. It's a delicate framework, susceptible to various constraints and limitations. One of the primary challenges is dealing with the ways a schedule can be limited. Let's explore 5 such constraints and the strategies to navigate them effectively. The first limitation often stems from resource availability. Resources, whether they be personnel, equipment, or materials, are rarely unlimited. To address this, project managers can employ resource leveling techniques, adjusting the schedule based on resource availability, ensuring that no resource is overallocated. This often involves delaying certain tasks until the necessary resources are available, thus ensuring that the project progresses without overextending the team or budget. Secondly, time itself can be a constraint, with client deadlines or market opportunities dictating the project completion date. In such cases, critical chain project management can be applied, focusing on the tasks that directly affect the project's end date and building buffers into the schedule to accommodate any delays in these critical tasks. Financial constraints also play a critical role. Budget limitations can delay or prolong the scheduling of activities. To manage financial constraints, cost-benefit analysis can help prioritize project activities based on their value and impact on the project's overall success. Then there's the limitation of technological or process interdependencies. Some tasks can't start until others finish. Here, project managers can use fast tracking, executing tasks in parallel that would normally be done sequentially, to shorten the project duration. Lastly, stakeholder availability and decision-making can delay project progression. To mitigate this, effective communication and stakeholder management strategies must be put in place, ensuring that stakeholders are engaged and decisions are made in a timely fashion. To develop a project schedule, one effective method is the Activity on Node (AON). This involves mapping out the project activities on a diagram, where each activity is a node and the dependencies between them are represented by arrows. The AON method helps in visualizing the project's flow and identifying relationships between tasks. It's a visual aid that allows project managers to see the entirety of a project at a glance, to better manage and adjust as needed. When it comes to identifying the critical path, the 2-pass and enumeration methods are invaluable. The 2-pass method involves a forward pass to determine the earliest start and finish times and a backward pass to determine the latest start and finish times. This allows for the identification of the critical path, which is the longest duration path through the network with the least amount of slack or float. Essentially, any delay in these tasks will delay the project. The enumeration method, on the other hand, involves listing all possible paths and their durations to determine which is the longest. Both methods lead to the identification of the critical path, where all activities have zero float. Adjusting a project sequence logic can sometimes be necessary, and this is where leads and lags come into play. A lead is an acceleration of the successor activity, allowing it to start before the predecessor has fully completed. A lag is a delay in the successor activity. Additionally, alternative dependencies can be established, like preferential or discretionary dependencies, which are established based on best practices or unique project circumstances. Accurate time estimation is often fraught with difficulties due to unknowns and uncertainties inherent in project execution. A typical problem faced is merging, where multiple predecessor activities converge on a single point, complicating the estimation of activity durations. To enhance accuracy, historical data, expert judgment, and reserve analysis can be employed to better anticipate and mitigate these uncertainties. Now, considering the objectives, let's weave in the answers to some key questions about project scheduling. Milestones, for instance, are pivotal, serving as checkpoints. They are not just about signing the project charter or the completion of the WBS, nor are they as frequent as weekly team meetings. Rather, milestones are typically identified for significant events such as the completion of a major deliverable, providing clear targets and points of reflection for the team. When estimating activity durations, a common issue is indeed merging, where multiple tasks converge and complicate the schedule. This is unlike the structured approach of using checklists and templates, reducing uncertainties, or managing non-critical activities, which all contribute to improving estimation accuracy. And as for the critical path, it is not about the shortest path, nor does it directly determine the project's end date, and it isn't comprised of activities with lag times. The critical path is the series of tasks that, if any were delayed, would delay the entire project, activities with zero float. Understanding these concepts and strategies helps project managers navigate the complex and often turbulent waters of project scheduling, ensuring a course that is as efficient and effective as possible.